Okay, we're going to continue 10-4, day 2. Okay, inverse functions.
Well, to be fair, it kind of is.
All right. It had nothing to do with agreeing, disagreeing. It has to do with your effort. Okay, come on. All right. So we are going to deal with inverse functions today of quadratics, okay, square root functions, all that kind of stuff. So on page 326, we'll be graphing this. F of x equals 2x squared, where x is greater than or equal to 0. All right, so the first thing is being able to graph, just ignoring this part, being able to graph f of x equals 2x squared. Tell your neighbor what type of shape that would be. Okay, that should be a parabola, right? You guys remember that? Okay, now let's think of our quadrants for a minute. If we have a 4-quadrant system and we're looking at just the x-axis, everyone draw that on their paper right now. I want you to circle the part of the x-axis that is greater than or equal to 0. Okay, I'm hoping that everyone circled that. We in agreement? No? All right. Any questions on why we're circling that? Okay, so here's my x-axis, right? Here's 0. Which side are the values greater than 0? Left or right?
Right.
The right-hand side. So over here. 0 on your coordinate plane is represented where your axes cross. So all these values are greater than or equal to 0. Okay? Now what this is telling you, it's saying we want to graph this under this domain. So in other words, we don't care about this part of your graph over here. Meaning, if I take this picture of my parabola, we don't care about this chunk of it. We only care about what's happening right here when x is greater than or equal to 0. Okay? So that's why I've zoomed in to this first quadrant in my grid. How many are good on that? Okay. All right. We're not done with the problem, obviously, but I want to go down over to number 10. Okay? On number 10, once again, you're thinking about your axes. I want you to circle the part that is less than or equal to 0. Okay, so on the x-axis, are we on the right hand or left hand? Yeah, we're on the left hand here. Meaning if I'm drawing my coordinates on this one, I need to be able to see at least the left-hand side. I'm actually going to look at all 4 quadrants here. But I'm only going to care about what's in this area over here. I don't care about anything over here. Very good. Okay. All right. So the next piece, this guy right here, when x is greater than or equal to 0. I want you to go ahead and think through the same thing again. Okay, so once again, we're on this side, yes? Okay, how many of you get the domain thing there? That's all that's asking. So the rest is just saying graph it. Okay, so let's go ahead and get our axes in here. We'll put these in. Okay, so let's graph 2x squared. We created a table of values. Hopefully we know where this starts. Where's this one going to start? Going to start at 0. Yeah, we put in 0 for x. We get what out? Yeah, we get 0 out for y. So when x is 0, 2 times 0 squared is 0. Y is 0. Y meaning f of x. So. Okay? So we end up with 0, 0. Okay? How about when x is 1? 2. How about when x is 2? 4. Oops, did I get that right? 1, 2, 3, 4. Unbelievable. Use a pencil. All right. Ignore the x point there. Okay? How about when x is 3? 3 squared times 2? 18, yeah. Right? Did we get 4 correct? No, what should it have been? 8. Unbelievable. There's 4, 5, 6, 7, 8. I'm really messed up now. Now I have 2x points. That's ridiculous. Hey, are we making sure that we getting that right? When I put f of 2 in, f of 2 is 2 times 2 squared. So that's 4 times 2, which is 8. That's why we should have an 8 right here. And when I put 3 in, that's our 18. Okay? Just really quick on our table. Now, if I'm graphing this, this would go from here up through there. Okay? All right. I want you to make sure you have that graph. I fixed my amazing graph there. At least the x is done. Okay? So now it says graph the inverse. Remember the instructions from yesterday say graph the inverse here. Okay? So we need to actually graph it, meaning we're reflecting it over which line? Y equals x. So if we had our dashed line here at 1, 1, 2, 2, 3, 3, so on, the y equals x line, these points are just reflected over. This point that is at 0, 0 is actually on the line, so it stays there. But the point that's at 1, 2 actually goes to 2, 1. So 1, 2 becomes 2, 1. Really? The x and y values just changed. I know, it's amazing. Okay. The point that's up here at 2, 8 becomes 8, 2. You're 8, 2? That's B's.
2, 1.
Okay. All right. And we have our graph. That graph now looks like a square root graph, which it actually is a square root graph. Okay, so if I find the inverse of this function, meaning I take that function and I solve y equals 2x squared for x, or I switch the two values, x and y, I call this one x, and I call this one y. So I write it as x equals 2y squared, and solve for y. So what's the first thing I'd have to do to solve that for y? Divide by 2. So we'd have x over 2 equals y squared. Tell your neighbor the next step. Hey, take the square root, right? And it is plus minus square root of x over 2. Hey guys, what's that? Yeah, we're not supposed to have a fraction in the square root, but that's okay. We're not going to worry about rationalizing that right now, at least on this. Hey, you guys, the negative portion, remember the negative, a positive square root graph opens up like that. A negative square root graph opens downward like that. Okay? So if I'm graphing a positive square root graph, or excuse me, this positive branch here, that would mean that this piece up here would also have to be a positive branch. Okay? Notice if I were to graph the bottom part of this down here, I would have 2, -1. Correct? You guys with me on that? What's the inverse of that point? -1, 2, right? That does not follow our range up here, or excuse me, our domain. Remember, we don't care about anything on this side of it. So this stuff over here we're not worrying about, which means when we reflect it, we don't worry about anything down here either when we're doing the inverse of it. Okay, so we don't have to worry about the negative portion of this graph, so we get rid of that. We're not worrying about that, just the positive. Okay. Okay, let's try number 10 there. Okay. Give it a shot. I want you to graph it on your own and then find the inverse of that function. You guys, if you remember patterns in graphing, this is a lot easier. Remember, x squared plus 5 just moves your graph 5 units up on the x-axis or the y-axis. Okay, so you're right here. And negative means it's opening downward. And we're only worried about one side of the graph. That's this side, right? Yeah, it's actually this side. Okay. So we're actually here. We go over one down 1. That's that part. 2 down, 2, 4. Okay. Get this chunk of the graph. Okay, that's the graph of F. We should label it. We didn't do that on the other graph. We should definitely do that. Okay, you got to make a table of values. If you guys can't do it using patterns, you have to make a table of values now. Okay? But I'm not going to walk you through making tables of values anymore. It just takes too long. Yeah. Dot should be up 1. Yeah, it should be up 1. Golly, man. And I would actually use a pencil, except for I have to use a pen on one of these. I just can't quit making mistakes. And usually I make them on purpose, but not today, man. Sorry, Sebastian. How about that? That.
What did you do?
And right there. All right. Sebastian, well done. All right. Much better. No, that's okay.
No wonder why my graph was off.
Okay, that's F. Hey, the inverse. Flip it over the y equals x line. Graph your inverse there. Really? Really? You sure? All right, this point right here would go
You can't do it.
right there.
No, you can't.
What do you mean you can't?
Because this is supposed to be only on the negative side.
Huh?
It's only supposed to be on this side.
That's the graph of F. Hey, yeah, this rule right here does not apply to the graph of G, the next graph you're doing. It doesn't apply to its reciprocal function. Or excuse me, it's its inverse function, not reciprocal. I'm stuck in trig there. Okay? This point. This point, it's at -2, 1, goes to 1, -2. This point, it's at negative 3, negative 4, goes to negative 4, 3, negative 3. We'll call that the graph of G. G.
That's a nickname.
Usually f of x and g of x. Could be h of x. Could be L of x. Z of x. Yeah. Okay?
Huh? No, my brother calls me G because he can't fully see.
How many got it? All right. Sounds like I'm losing Aaron there again. So y equals negative x squared plus 5. We're going to have to switch our x and y values. This becomes x. This becomes y. So we get x equals negative y squared plus 5. What's the first step? Subtract 5. X minus 5 equals y, or negative y squared. What's the next step? Divide by negative 1. Negative x plus 5 equals y squared. And we take the square root. Okay? Plus minus the square root of negative x plus 5 equals y. Well, you can't have a negative x plus 5. It just means that when you're done doing the math in here, your answer can't be negative. So like if x was negative 3, it would be negative 3, which would be positive 3. Which would be okay. But which one of these doesn't belong, the plus or the minus out in front? Yeah, it's opening downward here. Okay? So the plus doesn't belong. It's a negative. Okay? That is our inverse. So that should be negative out in front. Okay. If you want, you could write it like this. We're going to skip this one here. Okay, questions?
No.
All right, let's try number 12. Determine whether the inverse of f is a function, then find the inverse. Okay, so I would actually find the inverse first and then figure out if it's a function. That's easier, I think. Okay, the book will talk about a horizontal line test. If you graph it and it passes a horizontal line test, then you're good to go. I like to think of just doing a vertical line test. Okay, so let's first just find the inverse. Switch these values. That was y equals root x plus 4. To find the inverse, we just switch our x and y values and solve for y. So x equals the root of y plus 4. So now let's solve for y. What's the first step? Square it. So we get x squared is equal to y plus 4. The next step. Subtract 4. X squared minus 4 equals y. Okay, that is the inverse. Is that a function? How do you know if something's a function? Okay, if your x values don't go to, like they don't repeat themselves going to different y values, what does a picture look like that is a function? Can I see your graphing calculator, please? Minus, yeah. Quinn, do you have a thought on it? Okay, some straight lines are functions. Is that a function? Function passes the vertical line test. Remember the vertical line test? You lie a vertical line on the graph. If it hits it in more than one spot, then it's not a function. Is this a function? Does this vertical line ever pass or hit that graph in more than one spot at a time? No, it is a function. So yes, this is a function. It's a quadratic. we know what a quadratic is going to look like. It's going to be a parabola. Yes. All right. All right. Let's try another one here. Try number 15. Oh, hey, hold on. One last guideline here. What could x not be? X has to be greater than or equal to 0 here. Okay? X has to be greater than or equal to 0. That's a guideline or a restriction we have to have. Okay? All right, let's go on to number 15. Find its inverse. Last one we'll do as a class. So switch your values. Divide by 3. Take the square root. Is that a function? Bailey? Okay, can I come back to that? Is this a function? Yeah? Plug it into your calculator. You did? Can I see it? Thanks. All right, Kai put it in. Kai put in only half of it, though. He put it in the positive half. Okay? Where did the 9 come from? Here, I'm gonna switch it up. So I think Kai plugged in the wrong thing. That's okay. All right. So there's the positive version, but you also have to put in the negative one. Okay, so it has two parts. It has a plus minus root x over 3. So now when I graph that, I get that, and then I get its bottom part. Does that pass the vertical line test? No. Is that a function? No. Square roots are only a function if it's either positive or negative out front. If it's positive and negative, it's not a function. That's no fun. No function. Me and you, Jonathan, are on the same wavelength. Well done. You could be a math teacher when you get old. Okay, Bailey. Question on number 12. Bailey had a question. Go for it, Bailey. X has to be, you guys, X has to be greater than or equal to 0 here. Because when it has to do with this piece. Okay, so if we were to, I'm just going to do a quick sketch to describe this. So this graph right here does this, right? It starts out here at -4. That's the graph of f. So the graph of this right here is actually going to start over here at, it's not an amazing picture, but it'll do. Okay, that's the graph of g, if we call this one g of x. Okay, these values have to be bigger than 0. So you're restricting the values of g, not of f. That's why this would be greater than or equal to 0. So it's existing on this side of the x-axis. This graph is. That make sense? Okay. Everyone understand what he's asking there? It's a really good question because this isn't a restriction up here. It's down here. Okay. Your assignment